Alright, time for another draftphysics.com, debatephysics.com also, but still searching for the debaters. It's unfortunate that people just disappear like Piro, and, disappear in a more permanent sense with Hothloday. I kind of wish he was still around, uh, you know, just because at least he listened and, you know, felt some compulsion to defend his statements and to refute others. And so, even though the debate was a bit snarky, it was better than nothing. And nothing is what we have now, which is really quite irritating. So the point being made here is quite simple. Science isn't all that, okay, in the sense that, yeah, you can make anything come out the way you want it to. You can make it look a way. And, I've revealed in so many ways the fraud of the double slit experiment and the wave theory. Waves don't work, they don't explain the right pattern, blah, blah. I mean, I've been over it and over it. I pointed out how the Einstein's relativity has, kind of huge flaws in it. Namely, the first off one is that they've never really proven that light's bent at all by gravity, let alone bent twice as much. And they have a really simple experiment that would be decisive one way or the other, and they've chosen. Okay, and it's somebody made the choice. The decisions have obviously been made that this isn't important. Because in all the time we've been in space, they've never bothered to point an average camera, okay, outside the edge of the sun to video even this event of, light distorting the images of things behind the sun, or behind it in the sense of within, behind its corona, behind its gravitational influence. Let's put it that way. Significant, and yet you all accept that. Okay, yeah. Well, why does it have to prove anything? And I've gone over and over this kinetic energy thing for 2 years, explained that the history is rotten, that the experiments, the tiny little bit of evidence they had on one side, they have a huge amount of evidence on the other side, and that nobody thinks it takes 4 times more fuel to go twice as fast, and all of those things that they live with day to day that don't turn out to be kinetic energy. The idea of the gun violating Newton's third law, and they don't care. Okay, the bullet has 2,000 joules of energy. The recoil of the gun has 1 joule. Two. I mean, what sense does that make? Fitting in with a law they have some respect for, this equal and opposite reaction law. Complete violation. I showed the Mythbusters video that them, done also imperfectly, in that it's a TV show, so we don't get to see the important bits of establishing that it is twice the speed, and making sure they have camera angles that'll show that the experiment isn't distorted in some way or perverted. But clearly the cars themselves prove it also. No evidence of kinetic energy. The cars are showing half, twice as massive. You're going to go twice as slow, and you're going to have, half the pressure. And the whole thing is, it just shows right there in front of you that kinetic energy, 1/2 mv squared, isn't how it works. Okay, the lighter and faster I make something, I don't give it more energy. Because it's really just about momentum. It's about how much pressure you apply to something will decide how much damage you can do to it. And of course, how long you're going to apply the pressure is also matters. You can't go off and do something else before you've finished applying your pressure. So that gets into the whole elastic arguments and inelastic. But I'm saying it's not nuclear physics. It's really not. This isn't all that abstract. These are really simple concepts. Okay, I mean the fact that the double slit two-wave theory doesn't explain the real double slit pattern. The fact that it really should be observable. It should be proven within a well-established well-constructed experiment that light is twice as bent by gravity. And kinetic energy, again, the experiments don't show it. And they don't do the experiments that would show it. I mean, they don't do the, let's prove it takes 4 times more fuel. They don't prove it. And these are doable experiments, and they just aren't done because they're not conducive to proving what they want to prove. And that's what this is about. There's a want in here that's breaking the physics. And again, the Brozo experiments are just such proof of how you can have completely, you could repeat the experiment done poorly, and confirm just idiotic results. So he has one experiment where he says he's got decisive proof that it's 1.4 and not twice as fast. And then he does a pool ball experiment, on a lever that demonstrates quite clearly that it's not even close. That's not right. That it's really, really close to being twice as massive means you're going to go half the speed. So, it's right there in your face that, obviously these even simple experiments have to be done carefully. The Dispar guy had all kinds of trouble getting consistent results and finally gave up, apparently. And you won't concede that these extraordinarily complex experiments can't have tons of fudge factor in them, LIGO, even particle accelerators. But things that demonstrate that they just gave the Nobel Prize to the Alan Aspect guy. Another experiment's barely been repeated, at least the way he did it, and the proof is so abstract. It came out with a wrong probability, but it's all based on their assumptions. So I mean, they can't do the simple. They can't do a 2-slit experiment with any kind of rigor, and yet you trust them, telling you that infinitesimally small particles are somehow communicating with each other at instantaneous speeds. I mean, you go into all the reasons why that can't be true, and how the evidence demonstrates it can't, and their own theory of how these these entangled particles are forced to de-entangle is based on some notion that the only way we de-entangle them is when we look at them, when the universe is looking at them all the time. I don't know how anyone could believe the cat in the box is somehow not being affected by all the other radiation that's hitting it all the time. So how could it ever maintain any other state, than a real state? Whatever. It's just so bad. And you sit here and you say, nobody, nobody can bring any kind of reasonable counter argument. They can't show me 2 waves producing the double slit pattern. They can't show me any, experimental evidence besides evidence that clearly can be distorted. It can be bent to produce whatever results you wish to produce. So anyway, just quite depressing. Alright, so this week's videos is what we'll do. The website videos, this will be a crappy YouTube video. It's all quite depressing. There's so little, the subscription box is vacuous when it comes to anything interesting. Nobody's doing anything interesting on the internet. Even the conversation that John Chappelle people have become a little bit obsessed with this Faraday's paradox, and they can't, they're just wasting time because they can't even establish what it is that the actual facts indicate. That is what the experiments demonstrate. And so they can't even establish that, yes, when the 2 things are turning, there's electricity. When one turns and the other one doesn't, there's no electricity. But when the other one turns and that one doesn't, there is electricity. And this was a problem for Einstein. And again, Einstein didn't have any solution. And it's still a problem for their theory. All right. Yeah, I think that's probably enough. Anyway, the theory that there's no experiment you can do to find out who's moving, because it seems clear that it makes a difference whether the magnet moves or whether the object making induction, so to speak, is moving. Alright, so let's play some of these videos, pieces here and there, and that'll give us plenty to talk about. You know, pushing from one side, if it can go this way, it'll go this way. Or if it can go that way, it'll go that way. And then, I guess I was just pointing out how it's sort of, it's always a pressure equation, and the thing that gets affected is the thing that's easiest to affect in the equation. So, you know, it doesn't matter whether you throw a cream puff at the brick wall or you move the brick wall into the cream puff. The fact is, the cream puff is going to do all the acting. It's going to do, it's going to collect the energy transfer. It's going to do the math. So the thing doing the math will always be the most flexible. What's the right word? It might not be a right word for that kind of capacity to be under less pressure, to be less compact, to be less rigid. So saying less rigid isn't quite enough either. But anyway, that's the way it works. So the spring in the scale is more compressible, easier to compress than the person or the ground. So the spring in the scale will do it'll do the math. It'll do the conversion. It will take what's on one side, take what's on the other side, and it will distribute it, redistribute it evenly. Alright, yeah, that's enough of that. Let's jump ahead a little further. Something about the Earth degrade. Alright, so I was sort of pointing out that, you know, it's the center of gravity they always talk about, like gravity's created in the center of the Earth, and it's really not. It just ends up being in the center because it's a sphere. And it's a sphere because these lengths of line, if there's anything non-spherical, it's going to tend to create more gravity, which is going to tend to have the consequence, like global warming or something. There's going to be a feedback loop, and so when you increase one thing, you increase another thing, and so the mountain's going to end up getting eroded, blah 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 blah, all of that crap. So yeah, but the real gravity is being created by the whole length of the Earth underneath me is substantially creating most of the gravity I'm feeling, which is it has absorbed the pressure of the universe, and therefore there's a differential, and it's pushing me. So if you look at the universe, yeah, it all looks like, how would you, it looks like snowballs, right? I mean, how do you make snowballs? You take stuff and you push, you compress it, and it's a simple starting point. All right, so all these things are based on starting points, and starting points hundreds of years ago, and we all should be skeptical of accepting what somebody said 400 years ago and saying we're all going to say that was true, when maybe that wasn't the true view. So the view of waves and all this stuff got popularized hundreds of years ago, and that's the way people wanted to look at everything. And I don't know why exactly, but for whatever reason. And it's a wrong premise. It's a push universe. It's little bits of stuff that are doing all the pushing. The moon is all cratered because crap has hit it. It's pushing it, smashing it. And there's a bunch of little stuff doing that still. So unlike the meteors and asteroids that have died down, the clutter in the solar system has been cleaned up, caught, trapped by these big objects. The little force, no, you didn't stop that. That doesn't get all consumed. So you could argue that this is basically heat, and that's what you find. Okay, so it doesn't look like gravity, but somewhere in here is gravity, I guess. It's just pointing out how things absorb energy. So when you move matter, it takes a force to push it. The force is going a certain speed. The speed won't be the same when it's pushing something. Therefore, there's a decline in its energy while it's pushing. It's a consumption of its energy. And if matter just moves back and forth, obviously, it's not it can't be continually doing something in the universe that looks like energy, but it is consuming energy. It's a real motion. Any motion of matter in the universe has to be consuming some energy.
Times bigger than this.
Okay, so yeah, something obvious that was around hundreds of years. Why didn't they all agree on the inverse square law, for really simple reasons? I mean, it's just so obvious that, yes, that's a law of stuff bouncing off surfaces and bouncing back into your eye and all that crap. I mean, that's a law of imagery. And the universe is behaving based on that fact. Gravity's behaving that way in every respect, and so there's every reason to think it's being created by the same exact kind of force. Force moving at the speed of light. And something that simple gives you every indication that that's how it works.
It's good enough for me.
All right. Yeah. Well, I'm doing the best I can. Obviously, it's. For some reason, like I said, the people advocating something different just do not wish to participate in the argument, and that's unfortunate. I can't pay them to do it. I can't in any way engineer it, so it's only going to happen, I mean, somehow this website's going to have enough. It's going to have to gain enough visibility, and there have to be enough people falling for the lies I'm telling. Before these people feel obligated to do some debunking. But they won't be able to do that. So again, that's the whole problem. This isn't an easy target. This isn't flat earth science. The fact is, their science is crap. Okay, and there is no way to defend it. There's no way to defend not doing the Eddington experiment from space. You don't need an eclipse, and you don't even need a telescope. You just need a good camera. It's 400 times better visibility from space. No eclipse, 400 times better seeing. There's just no good reason. There's no good reason. There's no logic. There's no explanation that doesn't have something to do with, well, I guess blah, 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 blah. We don't want the truth. I think that's the only reason is, no, this will be inconvenient because it won't show what we want to show. Alright, so this was a comment video, I think. Yes, comments.
That's all it is. I mean, the fact that you could make we have nuclear submarines means we can have nuclear airplanes.
Yeah, I don't remember that exactly. Who was commenting, but this free energy crap is the whole subject here. Because it comes up in this that John Chappell organization has a lot of people that thinks there's this inertial energy bullshit, and you can sort of understand. You're never going to find that. There's lots of energy in the universe. The gravity right now is energy, but the problem with it, okay, is that it's like you're in a boat in a stream, and the problem is the gravity is also in a boat in the stream, kind of thing, right? You're not, if you can put your water wheel, attached to the land in the water, you can gain energy. If you put your water wheel in the water and just let it flow down the stream, you can't gain any energy. It's only the differential in motion between objects that will produce whatever this energy thing is called. And so you have to steal it from some place that it already exists. You can't get it some other way, because you're going to be in the same boat. If anything you pick up is going to be doing the same thing you're doing relative to space. And there's not some island somewhere you can attach to and say, look how much I'm moving. Well, you can't attach to some absolute quiet place, a piece of land. So if there's no land to tie your water wheel to, it can't rotate. You have to have it attached to an axle that's attached to something that's moving differently. And until you can do that, you're not going to get any of this free energy from the force in the universe. But we know we can get pretty almost free energy. Yeah, from splitting or fusing atoms, but that's a little tricky because it's dangerous. Something touches the bucket. You know, if I move something over here, a little stick. Okay, so all you got to do, right, so when something's falling in gravity, all I have to do is make contact with it with something that isn't falling at exactly the same rate, and I'm going to create friction. I'm going to create a way for that bucket to lose what it has collected. And the more substantial I interrupt what it's doing, the more substantial amount of energy it's going to give me. So it's like the brakes squeezing on a disc or a bicycle wheel. You know, it's just any contact is going to create friction. You can create a lot of friction, a little bit of friction. The contact is a way for the energy, okay, to leak out. So yeah, so I mean, you can understand gravity is just, it wouldn't be a burden to horizontal motion if it wasn't for the fact that you do have friction with surfaces, and how much it pushes you in is going to decide how much of your energy you can lose, how fast. The heavier you are, the more likely you are to give your energy away in friction, because you're going to stick to the earth more. Force pushing on this proton in that direction, and there can't be any pushing. Alright, so just explain to somebody who just didn't quite get the theory, okay, that electrons and protons, because of their opposite force, the force they excrete, means that yes, you don't need a strong force to bring two protons together. All you need is an electron. You stick an electron in there and you're negating force, and therefore allowing protons to be very close to protons. You don't have to push them together against a force. You just stick an electron in there and no problem. And that's perfectly consistent with Maxwell's drawing of charge. So again, another argument that's pretty simple, and you know, people should get it, and they don't. Scatter field here. You can't see, so you can just make. All right, so this is another argument about these 400 times you can see written there. You know, this is the Eddington experiment, and the fact is that in the corona of the sun, in the area of the sun that's full of, I mean, look, the area of the sun that's the atmosphere of the sun, obviously we already know that plasmas from the sun, a bunch of ionized atoms, does reach the earth. So I mean, it's a dirty atmosphere around the sun, and the closer you get to the sun, the dirtier and dirtier and dirtier it gets. And so if you're not too concerned with how much light you're going to bend, and that you just need to bend any at all, then yes, you're almost guaranteed to bend light to your placement. No matter where I put the earth here, that the people on the earth can say the sun bent the light, because you know, some portion of the energy will in fact hit those plasmas, will hit the atoms and electrons and protons that are being excreted by the sun. And by hitting those atoms, this is already a known, again, Compton's scattering, it's a known fact, that yes, there'll be a change in the direction of the momentum. You'll change the direction of the object, and you'll obviously be changing the direction of the energy that's going to be excreted by the motion of that particle. And that energy is going to be light, and it's going to be light that you're creating essentially by moving the electron or the proton. Every time a subatomic particle moves in the universe, it changes the light pattern heading in the direction. And the light pattern is the same thing as saying it changes the energy profile in the universe. It starts making things look different. You know, that's so obvious. If it looks different, it is different. Alright, anyway, that's always a good way to end, yeah. Alright, so let's see what this one was. Drafting about heat in motion. So yeah, this is an interesting subject, that motion is just heat in a direction. And you can understand this as laser beams and all kinds of stuff, that you can you can make things directional. You can take chaos and you could turn the chaos into a direction. And that's really all you're saying, really, is that everything that's moving is just really directional heat. And that if you make the motion non-directional, that is, you scatter the motion, you negate it as motion anymore, because now it's just doing this. But it's still the same stuff. It's still the same energy. Wobbling back and forth is just as much energy as, going 60 miles an hour in a direction. Between the two pieces of glass. So there's no way for physical interaction. So part of the argument being made here is that the only way you could dissipate your motion is through contact. And you have to have contact with not the elemental stuff moving, but you have to have contact with the physical objects, in the sense that you have to bring their force together, because the fact that you change the frequency of a force, you change how you blue shift or red shift it, doesn't mean that you've actually changed its real energy, the amount of actual energy quanta. You've just changed how it arrives and how something might be reacting to how it arrives. So you're changing the frequency of a tone. Okay, it doesn't mean the tone has more molecules vibrating. It just means you change the frequency. It's probably not a good example, because in that case you are probably increasing the density, because you're compressing a real atmosphere, which is different. I have to think about that for a while, whether you can make... See, that's another point that just has to be made, is that you have to be really careful analogizing wave-particle duality as a byproduct of people looking at water waves and seeing tiny similarities and saying those similarities are showing you the truth, when they were a complete dodge. They were fooling people. It was a bear and they were calling it Sasquatch. I mean, they're not the same thing. They only have some things in common, but they're not the same thing. Okay, you still have the same bits in the same space. So in a sense, you don't have any more energy. You've just changed the where the energy is located. Okay, so it's a tricky word, because energy is a word you would use for the stuff that's actually moving, and that's the little bits of force. And so you're really just saying where they've been collected. And the interesting fact is where they're collected, that is collected by matter moving, they actually have less energy, which is the ironic part. Probably could be drawn better. Jump ahead a little. Erase him. Okay. And then I would put another electron here and another electron here. Alright, so just pointing out how the atoms, obviously, that's another simple subject, okay? I mean, everybody's bought into this idea that electrons have to be moving 400,000 miles a second, and swirling around, and that every atom that's sharing electrons has an electron that's moving from both atoms and swirling around both atoms, and all this kind of crap. When you can simply make a magnetic model of magnetic monopoles, and you could establish as an absolute fact that you can put them in positions. If I arrange the magnets just perfectly, and we're not in gravity, we're not in something that's going to screw it up, that I could arrange magnets in such a way that they create an equilibrium. They have attractive forces to one, to the center, the nucleus, that's a south magnet, and the north magnets are attracted, but they're repelling each other, and they could be locked in positions. And that geometry makes a perfect sense. You can understand how atoms are just being made out of basically electron, proton, electron, or proton, electron, proton combinations. And those little combinations, those deuterons, are really just the building block. And you're just saying, okay, I can put them this way, connected, like Lego, and then I can put two this way, and I can put two this way. I can just start creating a geometric structure that would be very stable if I made it out of magnets.
So again, we have a hundreds of years ago kind of argument. Well, let's not go back that far. I don't know who first decided that atoms were solar systems, with a bunch of moving crap. So there might be an ancient reference to such an idea, but clearly it's tied to the whole Bohr thing and whatever. And again, this is a premise accepted by everyone, no argument about any other possibility. And I would say it's a silly premise that electrons have some kind of perfect, you have to understand that their speed has to be perfect, because even if you're saying they're being controlled by charge instead of gravity, and they still have to have a perfect speed to stay in the orbits. And how can all that happen? This seems incredibly unrealistic. And yet you all believe, because they say so, not because they prove so. Breathing infrared radiation won't do it any good. It can't lose its energy that way. Alright, so the point is sort of that, again, you can't really lose energy by reflecting energy from the universe. To lose it, you actually have to in some way make a contact with the matter and slow the matter down, because if the matter doesn't slow down, you're not going to be able to get rid of its extra heat, its extra energy, because the rest of the universe is just kind of elastic. It's a spring, and it just gives back what you put in, and it won't take until you get rid of the matter. So you have to excrete matter to get rid of excess energy. So something that gets hot in space, the argument would be is that it can't just thermally radiate. It's in a vacuum, okay, like a thermos bottle, and there's just no place for it to let go of the energy until it excretes a particle at a speed. And so that's how it can get rid of its energy, is excreting particles. Or it has to hit something that it can create a thermal bond to, where the other object will collect the speed of the motion of its particles. All right. Next, a wire, and you're reflecting it at a specific frequency. It's that signal that can create so that's induction. So induction is a side effect. It isn't the function of electrons being pushed in a wire. It's just a side effect that you change the signal being sent from the reflecting surface, because the reflecting surface is changing. So you can think of it as a bunch of people in the, when they do those things in stadiums where the people have cards, and they can all put up the red card, or they can all put up the blue card. Well, that's what the wire's doing. When you're putting electricity through it, the wire's essentially like that crowd in a stadium, and they're flipping cards constantly, changing the card color at certain locations. And it's that pattern that's causing a reciprocal flipping of cards in other objects. And when it starts flipping cards, when it sees blue, it flips to blue. When it sees red, it flips to red. When it does that, it's creating the same force inside of it that created the pattern in the other wire. It's just much weaker. You're getting back the signal you sent. You're getting the same signal back again, because it's reflecting off the other object. So anyway, so it's a little bit of an induction in there also. So not a bad video, I'd say. Heat and motion. Yeah. All right. Then another comment video. Very uninteresting comments, I gotta say, frankly, but whatever. Same thing's happening to the rope. So what happens? Yeah, proving that it's a push. So here's another simple concept. It's a push universe. All right, I say the speed of force. All right, I think any intelligent person ought to really say, you know what, that's what they should say, the speed of force. Because all of the forces, that is, all of the interactions we know of that take place in the material universe happen at the speed of light. All the interactions that depend on what we call a force are happening at the speed of light or near it, right? Electricity is a little bit behind, but you can understand why it's a little bit behind, because obviously it's not it's not traveling perfectly straight, like a fiber optic cable. It's light inside a cable, but it doesn't travel the speed of light because it has to reflect off the surfaces. It's not traveling a straight line. So it's obviously got to be a lot slower than the speed of light because it's not traveling a straight line path. That kind of stuff. I mean, this is kind of simple and obvious, and it's so irritating. But to have to explain how everything's a pole, I mean, everything that is called a pole has an inverted push. All you're doing is changing what's being pushed. And the simple one is the rope. I mean, it's an obvious, if you think about what you're doing, what the rope is going to have happen to it, it's clearly going to have your pressure pushing on elements of it in a direction. There's not going to be anything called a pull. There's just going to be you pushing on pieces of the rope. You want to make contact with this thing. So I was sort of explaining how first you have to establish friction with the rope. You have to compress the rope so you can establish a good contact. That is, you can put a bunch of your levers into their levers, so when you push, you'll be pushing against their brick walls. You have to put your own wall down into the substance, and now you can push on the pieces of the rope. I mean, it's so simple. And again, there should be some concession that, yes, this is how physics, we should establish that these mechanisms are how it functions, instead of having any illusions that that pull is a reasonable concept in nuclear physics, when it really isn't. Anything that looks like a pull, all you have to do is do a little bit of looking and you'll see that it's a push. Is doing work when there is a book on it. So again, the shelf doesn't do the work in the sense that... Alright, so this idea of work and the idiotic, again, this is sort of idiotic. This, that Professor Lewin would hold his briefcase up in a college physics class and say, I'm not doing any work. Well, what's the point of having the word work if it's really going to be so meaningless? The things you know to be work you're not going to call work and say there's no work involved because the briefcase isn't obviously moving. And the fact is the briefcase is moving, and the tension in his arm is proof of it, that his muscles are doing this, okay, that he's doing work, and it's going to get fatigued because he's doing work. And it's just a fact. And so why the lie? Why the deception of saying that we're going to have a word work that really is going to be so superficial, trivially, inapplicable. It's just not a useful word because it really doesn't get to the point of where there's an interaction taking place and where the universe is doing the math, right? Work would be any place the universe is taking two conflicting emotions, any two motions that aren't identical, right? There aren't any two lines that aren't parallel, and recognizing that there's a contact and there's going to be an event now, okay, where things are going to change because of the contact. And that's work. Work requires a contact. And that's what you're really trying to measure, is the change in the universe based on interactions. This is pitiful. Yield the bull is you. Alright, so I'm just sort of explaining how when a spring's compressed, it is in fact doing work. If you could measure the tension, the electrical tension. So if they made this thing out of plastic, let's say you put a spring and you have a plastic piece holding this side, clear plastic, and a plastic piece hitting here. The fact is that, if they use these photographic techniques and whatnot, they could see the stress. Because there's real stress, there's real pressure being applied. The atoms are, in fact, cycling. They are, the side's feeling the pressure going this way, this side's feeling the pressure going that way, and that math has to be done. And so if you did this in the right circumstance, you might be able to create some kind of piezo electric effect. So if you made this out of a crystal or something, the spring would yield a little bit, there'd be a little bit of vibration, and you could probably collect a little bit of electricity out of it perpetually. But it would be a very tiny amount, blah, blah, blah. So, not going to be the solution to any of our energy problems.
But there's real stuff happening while the spring is being compressed. Just like there's real things happening to your, the cells of your ass as you're sitting in your chair. Gravity is working on you all the time. Gravity's pushing you into the ground. The ground's pushing you back up. There's action happening all the time. Restates what I'm stating in a way that sometimes I don't really understand. Yeah, so it was a superior mind comment that was supportive, but it wasn't exactly the straightest line drawing I ever saw. Say 1,000 times. Right, so what's the difference? If something sits in this space bouncing 1,000 times, it's going to travel the same distance overall that if it's bouncing between these two long objects. So the fact is the particles themselves have exactly the same amount of energy, and that they're moving the same distance this way and the same distance that way. They're just doing it in a different way, right? One thing's doing it the long way, and the other thing will do it inside this tiny little space, but it's exactly the same energy. But the fact is that these two objects that are creating that container are going to be pressurized, higher pressure here than here. But the higher pressure is just a consequence of the proximity of the objects. And so I'm just saying, it's not a contradictory statement to say there's not more energy, but in fact there'll be more effect. Yeah. Good enough. Yeah, well, that's not a great place to leave that one. But that's really all it is. Matter reacts to matter based on proximity in the universe, and that's how it can get rid of its energy, is to have something nearby. It doesn't do it any good to reflect or to emit infrared radiation if there's nothing reflecting that radiation. So where do we go? This was the comment video, so we go to yesterday's video. So this was a draft on induction, which is really just the whole subject of how all this photon stuff and radio waves, all of the inductive kind of force stuff works. And the fact is that it's complicated. You have a lot of experiments. So the Faraday experiment, the Faraday paradox, for example. Then you have the wire shooting out of the magnetic field, and they have the circular motion, of a charged particle in a magnetic field. And you have, let's see, what else is there? There's just a ton of experiments. I mean, the two slit experiments. You have, so you have a ton of experiments showing different things. I mean, the fact that you have this interesting fact that the diffraction gradient, okay, the one that creates actual physical slits, that is, it creates little wires, all right, and then you send light through and you end up with images, okay, in different locations, and the images are spread for their color shifts. And so, you can use, creating spectral lines. And then you have the other kind of gradient, okay, the polarizing film, which works on a completely different principle, but in a way is creating the same effects, right? You can change you can change a dot pattern. You can change a frequency, a phase of a frequency by changing how far something travels. One thing travels this distance, one thing travels this longer distance, so you can change the phase of the two objects when they hit the timing. Or you can affect the timing by making one piece of light go through more material, or different layers of material, because with each layer, each transition, there'll be a consumption of a portion of time. And so this one will be slowed down. So the polarizing film is really not diffracting light or spreading light. It's just saying that this photon will go through two layers and be shifted twice. Okay, so it goes to a half wavelength out of phase, and then it goes to a full wavelength out of phase.
and the other one goes through 1, so it only has a half shift in its phase. And I suppose if you got really fancy with technology, you could create a third layer, with 3, layers. I don't know what the effect of that would be. That would just be doubling the first layer. So because all you're really trying to do is get from, there's only 2 states to be in. Sort of in phase, okay, you're close to being, if the event happens at the same time, if we're going to say, phases happening at the same time, when that's not really what's happening, but whatever. To preserve your Morse code, dot, dot, dot. You want the dots to be the same, and you want the same distance between them. And so the diffraction grating spreading, but the polarizing film doesn't spread it. It just transmits it out of phase. That is, half the light, the dots have been moved to the wrong location, till they arrive at the wrong time. Alright. I mean, there's just so much to the subject, so that's why it's a draft video, because I have to figure out in what order to go through what we can establish as facts. I'd say, yes, it's a pretty certain fact that it's about particles and it's about scatter, and that's all you're really trying to do is figure out who's creating the change in the universe. It takes energy to move my hand into the universe. The universe now has a change in the pattern created by my hand doing that.
This looks like a positive, from this point of view it looks like.
So it's really, yes, all this point of view stuff that we're really talking about atoms that, they don't what people say. The atom, depending on which way I turn it, it's going to look different. So I can give you a look at the atom where there's an electron right there in front of you. Now you'll see the electron. Okay, so if it was blue lights and red lights, that they were emitting, you could understand I could rotate the atom and you'd see blue, and then you'd see red, and then you'd see blue, and it's going to change based on what you're closest to or what's in the way. So if I put an electron, in front of me, okay, you don't see me. So if I'm the proton and you're looking, you're not going to see me. You're not going to see the red light. And if the electrons are over here and here, okay, both of them in the picture, then you can see me clearly. So depending on which way you're looking at the atom, it's going to look like it's going to look like a negative ion from one perspective, and it's going to be a positive ion from another perspective. And that polarity is, that true magnetic kind of polarity is really essentially what's happening when these atoms are being, not only do they gain momentum, they change their position. And changing your position is just as much of an influence on the universe as changing where you're going.
The electricity is going this way.
It's saying that it's in the induction, that's part of the feature. So this is more on induction and how it's just this, again, the pattern changes on the wire, what it's excreting, because the atoms are changing what they're showing you. Red, red, blue, red, blue, red, blue. And that's what's causing everything else to react. So it's more of the same as was made in the other video point.
So, pulse.
This is the antenna part. So the fact that the light is polarized, that is, it has this shape thing. It's going this way, or it's going this way, or it's going this way. It has some sort of shapeness to it, and it's not an insignificant dimensions of shape. And the shape is really just defined by how far you can go at the speed of light at a certain frequency. So the higher the frequency, the smaller the distance you have to travel. So you can only go this far at the speed of light if you're 500 nanometer light. You can only go a tiny distance, not literally this distance, but I'm just saying it's small. And then you have to get bigger and bigger and bigger as you go to lower and lower frequencies, because it takes longer to get, you have more time to go further. Let's put it before the frequency, the next iteration, the next iteration, the next iteration.
So how far can you travel before the next piece in the frequency shows up? And that's that defines the ideal antenna length. Our harmonics of that, of course. So much to these subjects, and that will keep going in the direction once you've initiated it. You've essentially given you've created a sustainable force. So I'm really just pointing out, once you change that external pattern, you change how the force is hitting an object, that can recreate the same effect in the other object. Some way to say that. So it's a lot like an ether theory, in the sense the universe is pressurized. You can create changes in the pressurized field, and they will be receivable by something at a distance, just like my image is receivable by you, okay, because it's being essentially sent through the medium of a bunch of reflected energy traveling at the speed of light. All right. I think that's probably enough. Yeah,
So
there we go. That's enough. All right. So, enough of a video and such, and so forth and whatnot. Yeah, like I said, I wish there was something more exciting and interesting, but you can't do any of that. I mean, trying to contrive your counter arguments. I can't be stupid enough. I can't figure out how you can defend things that are really undefendable. I mean, there's no way to create the nonsense you would have to believe to defeat any of these arguments, because they're not defeatable. They're perfectly sensible critiques of not only the past science that's been done. I mean, the whole fact that this whole kinetic energy theory, 1/2 mv squared, first off, there was no 1/2 in front of it, so it was getting really wrong answers for most of its history. For 200 years of its history, it got really wrong answers, and no one cared. And why was it believed? It was believed because somebody was dropping round little steel balls, or copper, into clay, and saying that, well, there wasn't a directly proportional relationship between how much clay was displaced. And again, that can be explained is because as soon as you drop a round object, as I've pointed out, you drop a round object. I mean, I can almost use this drawing on the board that's here. So I'll do that. Just get rid of this. Alright, so you have a round object falling into clay. And the trick is that depending on how deep you go, how much energy you have, obviously the first tiny bit of surface that hits is going to be this bottom part. That's the part that hits first. And it's very flat. So it has to push the clay sideways. Alright, and so it has to do it by going down, because that's what the flat is going to do, is make a direct arrow down. It's not going to do anything other than do what seems kind of obvious. It's going to make it's going to do down, right? It's flat. It's going to apply the energy straight down. Now, as you go further and further on this arc, the energy is getting pushed more and more in this sideways direction. So you have the most energy used going down here, and you really have to move the clay this way, right? Going down is creating higher pressure resistance from this clay here is going to resist. There's no resistance going this way. It's just the atmosphere. So going this way, you just have atmosphere. Going this way, you have all these clay molecules you have to compress. So obviously, the cream puff, right, the weaker place for the energy to go, the energy goes to the weakest link. The weakest link is this way, sideways. Alright? So the more of your interaction involves this bottom versus this sideways, the more you're going to have to use. You won't be able to penetrate as far because this requires 2 conversions, where this doesn't require 2 conversions. And that's the key difference. So for you to do the experiment and get the right answers, what you do is you have to give both objects, the one that's
the one that's one mass versus two mass, and you have to give them, or one drop from, that's the thing, drop it from the same mass, drop from 4 times the height and 1 times 1 unit of height. So you're going to do that, and you're going to say that this one creates 4 times the dent in the ground. Well, the only way it's going to do that is if you don't give it enough energy to get all the way through the clay. So both of them, both objects have to get past this line in terms for them to be equally affected. That is, use up the fact that one of them is going to have more of this as a percentage of its interaction and less of this. See, you understand, the more deeper you go, the more you balance how much of the clay you're pushing this way and how much you're pushing this way. So obviously the one that's going from 1x is going to be doing more of this, because this is as far as it's going to go into the clay. So it's going to miss out on this in terms of its average. Its average is going to be this 9 plus an 8 plus a 7. So its average is going to be 8. Okay, where if you go all the way to 1, the average is going to be 5. So the one that falls from the higher distance has an average of 5 resistance, where the one that travels the shorter distance has a 9 as the average resistance. So obviously its energy was dissipated more effectively, for the lighter object, because there's less resistance to that dissipation. That being revealed in the clay. So I mean, it's a real science. It's a real physics argument, and it won't be countered. But the fact that this stupid experiment, not recognizing that the shape of the object makes a difference to how far it's going to penetrate. I mean, it's that simple, right? I'm making an argument so simple. I'm just saying that basically, hey, there's a big difference from having an arrow point on your arrow and then just having a round ball, or just having a square object on your arrow, right? That this one's more likely to get through the object than this one or this one. It's the physics argument is this damn simple, and this fooled people, in 1725 or whatever, 1740. This fooled people in 1740. They didn't recognize the difference between hitting a surface with this shape and hitting a surface with a round shape versus hitting the surface with a flat shape. They didn't recognize that would create a difference. And the difference is as obvious as putting an arrow tip on your arrow. That's how obvious the physics is. And here it is 200 years later, and I still have to explain how pointy things go through objects easier than not pointy things. But that's it. That's the only evidence they have. That's it. This is their experiment. So like the Eddington experiment, they have this piece of crap, and they have a whole theory based on it, a whole frickin' explanation of how the world works based on this completely idiotic experiment, where they're not accounting for something so obvious that it matters what shape the object is you're dropping into the clay. It matters whether it has a point or not. So I shouldn't have contempt for you people? That you would continue to defend this terrible, awful science? I mean, you're despicable. It's terrible physics. Alright. So enough. So till the next time and such. Shit. Yeah. Did I say in this video that I really hate being on this planet? I mean, you people are just despicable. You're awful. You're terrible thinkers. You can't do logic for shit. I mean, it's disgusting to be among you. Ugh. God damn it. So, this has been a draftphysics.com, debatephysics.com, but you're all too fucking cowardly to do any of that. So it ain't happening. And such. So, till the next time. And such.